Right, in this video, I'm just going to go through some common electrolysis exam questions. Here, they've set up the circuit for you. They're using carbon rods, so graphite is carbon as the electrodes, and they've set this up. And they've asked you for an improvement that can be made to the circuit to show that a current is flowing. Okay, this is more of a kind of physics electricity question. If you want to show that a current is flowing, you can put something into your circuit that proves that. So the obvious thing would be a bulb. Okay, if you put a bulb in your circuit and the bulb lights up, you'll know that current is flowing. If the bulb doesn't light up, you know that current is not flowing. So a bulb would be the obvious answer there, but you could also use an ammeter, which measures current in the first place. That will also do the same job. The question on the opposite page asks you which of J, K and L are electrolytes. Remember, to be an electrolyte, you have to be an ionic compound that can conduct electricity. And ionic compounds only conduct electricity when they are liquid or aqueous. So if I look J, K and L, okay, solution J does conduct electricity, K does not, and L does. That means J and L are electrolytes, K is not. So your answer there is going to be B. To be an electrolyte, it has to be able to conduct electricity. If you look at the next question down here, you're talking about electrolyzing copper sulfate solution. And this is what you end up with. You can see that the mass of the anode starts at 1.16 and ends at 0.85. So the anode decreases in mass over the course of the experiment. The cathode increases in mass, and it wants to know the mass of copper deposited. Your cathode is negatively charged. Copper is a metal and will be positively charged, so copper is going to go to the cathode. The cathode starts with a mass of 1.28 and ends with a mass of 1.57. The reason you're getting that increase in mass is because the copper is going to the cathode and it's building up around the cathode, making the cathode heavier. So to get the answer to this question, you just need to do a simple subtraction, and that will tell you the amount of copper you have forming at the cathode. This is a typical exam question about products forming. When you're asked one of these questions, you need to underline whether it's molten or aqueous. In this case, it's molten. That means no water is present. All you've got is the metal and the non-metal. There's no hydrogen, there's no OH minus. The anode, I know, is positively charged. The cathode is negatively charged. I know that metals are positive and will go to the negative cathode. So the metal is going to form at the cathode. The non-metal is going to form at the anode. And I'm going to write the names of those elements just as they appear on the periodic table. I'm not going to use symbols, okay? Because if you do use symbols, K is fine for potassium, but I is not okay for iodine. It's diatomic and you'd have to write I too. To avoid making any mistake with symbols, just write the name. It's easier. You won't make a mistake. This question is similar to the one that we saw on the previous page. Except this time, instead of just asking you which ones are electrolytes, they want you to explain. In this case, J does conduct electricity and K does conduct electricity, but L does not. So J and K are going to be your electrolytes, J and K, but you must also explain why they are electrolytes, and you will say J and K conduct electricity. Okay, so you get that from the table. J and K because they conduct electricity, but then you would need to say why they conduct electricity, and because their ions are free to move. J and K conduct electricity because they have free moving ions. So anytime you're asked about conducting electricity in these questions, be more specific, okay? Give a little bit more detail. The reason ionic compounds can conduct electricity is because they've got ions that are free to move, and that will only happen when they are liquid or aqueous. In this case, you're talking about a solution, so they're in aqueous form. Those ions are free to move, and that's why they're conducting electricity. Beneath, which material is most suitable to make electrodes for the electrolysis of a dilute acid? So they want to know which material is most suitable for an electrode. The answer is going to be graphite. Okay, so we looked at graphite and we looked at platinum as two suitable materials for use as an electrode. Zinc and iron, they're both metals just like platinum. So they both have high melting points. They both conduct electricity. However, they are both reactive, and if you use zinc and iron as electrodes, they could react with the ions that you have from your ionic compound. So you're not going to use zinc and iron. Sulfur is not a metal at all. It's a non-metal and it wouldn't conduct electricity, so it would not be suitable. So your answer there is going to be graphite. So another question here, explain why sodium chloride solution can conduct electricity. You would have to talk specifically about the ions. So you would say that the ions can move freely or are free to move, so can carry currents. Make sure you are mentioning the ions in your answer. Just saying charged particles is not enough. The next question, it says that you tested the solution with litmus paper and it turned blue. Why does it turn blue? This relates back to the acids topic. Litmus paper turns blue in an alkali. So you would need to say that it turns blue in an alkali. And you need to go further than that and say what an alkali is or what ion is responsible for, responsible for something being an alkali. Turns blue in an alkali. Due to the OH minus ions. So you're getting a mark there for mentioning the word alkali and also for mentioning the OH minus ions. Here, write a half equation for the formation of hydrogen gas from hydrogen ions at a negative electrode. So they're asking you for the half equation of hydrogen. Hydrogen as an ion is H+. I want to form normal hydrogen again. But I know that normal hydrogen is not just a hydrogen atom, it's a H2 molecule. If I've got two hydrogens on the right, I need two hydrogens on the left, and I always balance with big numbers at the front. Each of these hydrogens needs to gain an electron. I've got two of them, so I need to gain 2 electrons in total to form H2. The next question, molten zinc chloride can be electrolyzed. Describe how this can be carried out in a lab, explaining how the products of this electrolysis are formed. So there's quite a lot you can say in this one, but there's a few things you have to mention. They're asking you how you could do this in the lab. So the first thing you're going to need to mention is how you're going to melt your zinc chloride. Okay, so molten means melted. You're starting off with a solid. How are you going to melt it? So I would put zinc chloride in a crucible, is typically what we would use, in a crucible, and heat strongly. The crucible is just like a little clay pot that you can pop on top of a Bunsen burner. You heat it strongly and you can melt your zinc chloride. Once your zinc chloride is melted, I mean, it's the same thing that we've been looking at in all of the videos. You're going to have to describe an electrolysis experiment. So what we've been doing in all of those diagrams, you're basically going to have to describe this. So I would say, and heat strongly, place your molten zinc chloride in a beaker. Into that zinc chloride, you're going to be inserting your electrodes. Insert electrodes. What are those electrodes connected to? They're connected to a battery. Insert electrodes. Connected to a battery. Okay? And then once your electrodes are inside your molten solution, what is going to happen? The zinc ions, because zinc is a metal, are going to be positive and they're going to move to your negative cathode. So your positive, even if you don't know the charge on zinc, you can say the positive zinc ions move to the negative cathode. What happens to the zinc ions once it reaches the cathode? you could write yourself a half equation, or you could just remember that at the cathode, it's always reduction. So you can say zinc ions gain electrons, zinc ions are reduced. And then you could talk about what happens at the other electrodes where you've got your chlorine, so your negative chloride ions will move to the positive anode. And what's going to happen to them there? Well, they are negative, so they are going to need to lose electrons. So you can say your Cl minus ions lose electrons, so your Cl minus ions are oxidized. There's lots of other detail you could mention, so you could go into a little bit more detail about the battery. You could talk about the DC current that flows through. You could give a half equation here. You could describe what you might see. So zinc is a metal, so when that metal forms, you'll see that metal form around the cathode. Chlorine is a gas, so you'll see bubbles forming. But this alone would be enough to get you your 6 marks. Just talk about melting it first, and then I would draw this diagram as well and label it and fill it all in, and then I would write a few bullet points to describe what is happening in that process. The next question, they give you an example of a reaction. You're using sodium chloride solution, you're getting chlorine at one electrode and you're getting another gas at the other electrode. And they want to know what's the name of the electrode where chlorine is formed. We know chlorine is a non-metal. Non-metals are negative, and negative non-metals go to the positive electrode, which is actually labelled here for you. The positive electrode is called the anode, so that's going to be B. Write the half equation for the formation of chlorine gas. You're starting off with Cl minus. I want to make it Cl again, but it's not going to be Cl, it's going to be Cl2. I need a big 2 on the other side. 2 Cl minus, they each need to lose an electron, so you're losing 2 electrons in total. So writing these half equations, make sure you're always starting with an ion and ending with something that is neutral. It also asks you then to state the name of the colourless gas X formed at the negative. So in this case, it's sodium chloride solution. So you've got sodium, but you've also got hydrogen from the water. Remember, solution means that it's dissolved in water. So as well as having sodium, you've obviously got hydrogen. You're forming a gas at the negative electrode because you're forming hydrogen. Okay, between sodium and hydrogen, hydrogen is less reactive. Hydrogen is going to be the one that forms. It's a giveaway that they've said it's a gas. Sodium's not a gas. So hydrogen is going to be the gas that forms. A simple test that would show that an alkali forms in solution. If you want to show that something's an alkali, you would use an indicator. So I'm going to name an indicator. I'm going to say universal indicator. But it's not enough to just name the indicator. I'd also need to say what colour I'm going to see. Universal indicator turns blue in an alkali. You could also use litmus paper. Litmus paper will also turn blue in an alkali, or maybe even just a pH probe. You could put the pH probe and the reading should be above 7 if it's an alkali. The last question here, solid sodium chloride does not conduct electricity. Explain why. So as a solid, the ions are not free to move. In solution, the ions are free to move, and when those ions are free to move, they can carry current. So make sure you're mentioning the word ions, not just charged particles, and then make sure that you are mentioning current at least once in your answer.